Welcome to Space Center Houston's Thought Leaders Lecture Series. Today, we cover climate change and NASA's efforts to address its impact on our planet. I am Dr. Lance Hulbert, Program Director of Environmental and Public Health Education and Engagement at UTMB Health, which sponsors this series. At UTMB Health, we understand the importance of a healthy Earth for a healthy population. Climate change and environmental factors directly impact our collective future. On the Gulf Coast, we're at risk for an increase in destructive weather. UTMB is working to build resilient communities and reduce environmentally linked health threats, including preparing for natural and man-made disasters and infectious disease outbreaks. NASA has taken a leading role in studying and recording the impact of climate change. Tonight, we will hear from Dr. Catherine Calvin, NASA's Chief Scientist and Climate Change Advisor, and Dr. Kurt Costello, Chief Scientist of the International Space Station Program and Deputy Manager of the ISS Research Integration Office. Their work examines the challenges of climate change, its impact on NASA's priorities, and how they address these challenges. This work is of great importance to every creature living on Earth. As UN Secretary General Antonio Guterres once said, "The climate emergency is a race. We can win." Thank you for joining us, and we hope you enjoy the lecture.
Thank you for joining Space Center Houston's April Thought Leaders Series program, NASA's Climate Change Initiatives. I'm William Harris, President and CEO of Space Center Houston. We're a space exploration learning destination dedicated to bringing people and space closer together. As space enthusiasts, we're passionate about expanding knowledge and access to space exploration learning and training. We have the privilege of serving as the official visitor center for NASA Johnson Space Center, where we share the story of human space exploration, past, present, and future. Our Thought Leaders series brings you space and science experts from across the country who provide insights and perspectives on space exploration, a truly unique educational opportunity. I'm delighted to welcome our panelists for our April 2023 Thought Leaders series, which highlights NASA's climate change initiatives, presented by the University of Texas Medical Branch, Galveston. This is sure to be a dynamic and informative presentation. And as we celebrate Earth Day in April, there's no better time to talk about climate change. First, I'd like to introduce Dr. Catherine Calvin, NASA's Chief Scientist and Senior Climate Advisor. As Chief Scientist, Dr. Calvin advises agency leadership on the agency's science programs and science-related strategic planning and investments. As Senior Climate Advisor, she provides insights and recommendations for the agency's climate-related science, technology, and infrastructure programs. Since 2008, Dr. Calvin has been an Earth scientist at the Pacific Northwest National Laboratory's Joint Global Change Research Institute, or JGCRI, in College Park, Maryland. She worked in JGCRI's Global Change Analysis Model, a system for exploring and analyzing the relationships between human and Earth systems in the context of global climate change. In almost 14 years at JGCRI, Dr. Calvin co-authored over 100 publications. Her recent publications have investigated growing populations against agriculture and water scarcity in the face of climate change. Dr. Calvin received her doctorate in management, science, and engineering from Stanford University and a Bachelor of Science in Computer Science and Mathematics from the University of Maryland. Welcome, Dr. Calvin. Next, I would like to introduce Dr. Kurt Costello, International Space Station Program Chief Scientist and the ISS Research Integration Office Deputy Manager. Dr. Costello ensures science leadership at the highest level within the ISS Program Office, representing all research and researchers on the space station. He provides independent scientific advice to the program regarding NASA research, ISS National Laboratory research, international research collaboration, and scientific communications. Dr. Costello joined NASA in 2000 as an electrical power and thermal control training instructor in the Mission Operations Directorate. He proceeded to become an ISS Station Training Lead and the Group Lead for the ISS Daily Operations Group and Plug-in Plan Utilization Officers, also known as Pluto, before moving into the ISS Program Science Office in 2012. Since 2015, Dr. Costello has served as the ISS Deputy Chief Scientist and the Program Science Office Manager. He served as the ISS Chief Scientist since 2018. Dr. Costello earned a PhD and a Master's of Science degree in space, physics, and astronomy from Rice University, and was a double major with a Bachelor of Science in Physics and a Bachelor of Science in Mathematics from Thomas More College. Welcome, Dr. Costello. We're so thrilled now to hear from our panelists, and we'll begin with Dr. Calvin.
Thank you, and thank you for having me. So as mentioned, I joined NASA in January of 2022. Before that, I was doing research on Earth and climate change, in particular looking at how climate and Earth has changed in the past and how it might change in the future. But you can't understand Earth without really observing it. So NASA is a space agency, and as a space agency, we have this unique ability to look back at Earth from space. This image is called Earthrise. It was a photo taken in 1968 by astronaut Bill Anders on the Apollo 8 mission. And the photo offered a really different perspective at Earth. It showed Earth as this beautiful blue marble that we can see from far away. And it moved people to really think about the environment. You'll see it hanging on the wall behind me in my office. For me, it's really a reminder of why we do what we do at NASA, for science, innovation, inspiration, and home. NASA's been doing research on Earth since it launched the first Earth-observing satellite in the 1960s. And so today what I'll do is give a quick overview of how NASA studies Earth. So by studying Earth, we can see how it's changed over time. Observations made on and above the Earth's surface have shown that its climate is changing. 2022 was tied for the 5th warmest year on record, and collectively the last 9 years have been the warmest since modern record keeping began. We're not just seeing increases in temperature here on Earth, we're also seeing other changes in its climate that affect people and ecosystems all around the world. So we see declines in Arctic sea ice, increases in sea level, and increases in extreme events like heat waves, heavy precipitation events, and wildfire. And these are affecting people all over the world. But we understand many of these changes, and that gives us the ability to help prepare for the future. One of the ways that NASA studies the Earth is by observing it from space. We have more than 24 satellites and instruments in orbit, including several on the International Space Station, that are continuously looking back at Earth. Each of these is designed to look at something different and to measure a different quantity and how it changes. And as a result, we can see things like sea level rise, clouds and precipitation, vegetation, changes in the mass of ice sheets, and much more. And we've been observing Earth for decades, so we can see not just what it looks like now, but also how it's changed over time. I'll give a couple of examples of some of the observations that we have. First, the Global Precipitation Measurement Missions, or GPM, use satellites to measure rainfall and snow on Earth. And we do this in near real time, so we can show how precipitation changes and what's happened in the very recent past. This particular animation is showing Hurricane Harvey as it travels through Houston, and then we can see the amount of rain that fell and came to East Texas. Each satellite and mission is designed to measure something different. So as another example, we have a pair of satellites called GRACE Follow-On, or GRACE FO, and these use gravity and lasers to measure changes in mass on Earth. And we can use that to understand things like ice sheet loss. And so what these two satellites do is they chase each other around the globe, measuring changes in gravity and gravitational pull, which tells us how the change in mass under that, how that evolves over time. And so we can see things like how ice sheets have melted and how that water moves from the ice into the ocean or elsewhere around Earth. And so this is using gravity to measure a different quantity than what the GPM mission was doing with rainfall. And each of our instruments is designed to measure something different, and together they give us a more complete picture of how Earth is changing and what it looks like today. In addition to using satellites and instruments in orbit, we also have field campaigns that help us understand Earth and its changes. This includes both aircraft campaigns as well as research on the ground itself. And these are really designed to complement our satellites. So for our aircraft campaigns, one of the things you can do is more high precision measurements because you're closer to the Earth's surface than you would be in a satellite. But you're only measuring what you fly over, and our satellites are moving continuously. Our aircraft campaigns are designed for specific target measurements. This particular image is showing you the NASA ER-2 flying over a thunderstorm as part of a field campaign to help understand how intense summer storms in the central US can affect atmosphere and climate. One of the questions I often get asked, we're researching climate, but what else are we doing? How are we helping people address climate change? And one of the things that NASA does is develop technologies that can help people all around the world respond to changes in climate. Just as one example, our aeronautics team has worked with the aviation industry for decades to help reduce the environmental impact of aircraft. That includes doing technology changes and changes in operations that help reduce energy use and emissions, as well as developing new technologies. So this particular animation is of the X-57, an all-electric aircraft. And one of the big priorities at NASA is to share everything we learn with industry and people around the world so that they can use what we learn in their own operations and development. Sharing our information and working with private actors, it's throughout the agency, not just with aeronautics. So a lot of what we've done is develop partnerships with the private sector to facilitate the transfer of our technologies. Some of the technologies we developed to explore and live in space have benefits right here on Earth for sustainability. This slide is showing an example of one particular company, Eden Grow Systems of Houston, which built on decades of published NASA research on growing crops in space and used that to develop things that we can do here on Earth. In particular, they've created these automated energy efficient aeroponic towers for growing crops and seafood here on Earth. In addition to researching climate and developing technologies that can help people address climate, we're also experiencing it. So many of NASA centers and facilities are on low-lying and coastal regions, and they're vulnerable to things like sea level rise and flooding and storm surge. We also have centers out in California that are vulnerable to wildfire and drought. This particular image is of the Kennedy Space Center. Here they do shoreline restoration both to protect Kennedy's infrastructure as well as wildlife on the Florida coast. As I mentioned, a big part of what we do is try to share with people all around the world so they have access to the information we do and they can better prepare and plan for their what's going on in their communities. As part of that effort, we are launching an Earth Information Center this year. This Earth Information Center is designed to help engage and inform people about the changes that we're seeing here on Earth and help provide actionable information so they can understand and respond to the changes that they're seeing where they live. We're continuing to add to the information that we have. So just this past month, we launched a satellite called Tempo that's going to help monitor air pollution over North America. It's part of a constellation with other satellites monitoring pollution over Asia and Europe as well. And we're working towards the next generation of Earth observing satellites called the Earth System Observatory. These will give us more information about Earth, helping us understand what's happening here and providing actionable information so that people can respond to changes where they live. Another question I often get is how can people help? What can people do in their own lives? And one of the things is that you can help us do our science. So we have a lot of citizen science projects where you can use your cell phone to help contribute to NASA science and NASA's understanding of Earth. And so there's many of those that we have looking at different aspects of the Earth, all using just a cell phone. So as we explore space and the unknown, we continue to look back at Earth and learn from those experiences. This image is a selfie from Orion that includes the Earth and the Moon in the background, and it was taken in late 2022 as part of the Artemis 1 mission. The science and climate that we are doing from space and here on Earth help us better understand Earth and how it's changing, and understanding Earth helps us better prepare for it. Thank you.
Thank you, Dr. Calvin. I have so many questions. I can't wait for our discussion section. That was a phenomenal orientation to what NASA is currently doing to help us understand our planet and climate change. Now we'll hear from Dr. Costello.
Thank you, William, and thank you, Dr. Calvin. You have truly an impressive job to cover all of the initiatives that NASA has going on for both earth sciences and studying climate change. One of the major points of the International Space Station is really being able to provide benefits for humanity. And I'm glad to be able to introduce to you today some of the points of our International Space Station that really contribute to these initiatives for NASA. First off, if you recall in that image that Dr. Calvin showed, there are many, many satellites engaged in Earth observations, and the ISS is in orbit around the Earth at an inclination. So while a lot of those satellites in the first image were going around in a polar orbit or around the polar caps of the Earth, the ISS was launched at an inclination, so it kind of flies on a diagonal. And as such, it covers about 95% of the populated surface of Earth, which makes it a great platform to put instruments on to observe that portion of the Earth. Also, because it was launched at an inclination and it orbits about 16 times a day or once every 90 minutes, the orbit precesses a little bit. So instead of going over the same spot on Earth at the same time of day, the instruments on the ISS are able to capture what happens to the surface of the Earth throughout an insolation pass or at different times of the day. We like to call these diurnal effects. So you can start to see how microclimates in the afternoon may be different than in the morning. And so we have many, many instruments on the outside of ISS. This slide just shows you where some of them are located. Most of them are on what we call external platforms, and we have these located along the truss or that horizontal segment of the ISS you see in the background. And some of our newest instruments like EMIT are on that section. The other section, most populated for external viewing instruments, is our GEM exposed facility. This is attached to the Japanese experiment module and hosts many different Earth observing payloads and other payloads from both the US and Japan. Among those are OCO-3, the Orbital Carbon Observatory 3, EcoStress, the Ecosystem Spaceborne Thermal Radiometer Experiment on ISS, JEDI, the Global Ecosystem Dynamics Investigation, and Hisui, which is a Japanese investigation looking at climate change as well. But not only do we have external viewers of our environment and the Earth's surface to understand climate change, we have the unique aspect of having crew members on board. Those crew members see the Earth from a different perspective than they do when they're down here in training. They get to see an Earth without borders, an Earth where significant climate change can be observed from space. And they're keen on taking images. This is an image of Jessica Meir, one of our astronauts taking imagery through the cupola, which is one of our two major window research laboratories on the ISS. Why did they take this imagery? First off, the ISS is part of the International Disaster Charter. So as we understand, as we see the effects of humanity on climate, we're seeing more and more extreme weather events, and sometimes the results of those events can be captured by our crew members on orbit. This is an image taken from 2018 of the fires outside Mendocino National Park in California. As Kate also alluded to, we see large climatological events such as hurricanes from the ISS, and that data can be provided. This is Hurricane Harvey again, to the ground in their post-analysis for those storm events. Here's a close-up of that GEM exposed facility, and you see all around the facility there are 12 attachment points, and we have payloads in many of these locations. This is a great observing platform because it looks down on the surface of the Earth. But for other investigations at the end of the platform, we can also look at the limb of the Earth. And there we see that the atmosphere of the Earth is tenuous. It really doesn't exist above 250 miles where the ISS sits. And so a lot of research can be done as light sources pass through the limb of the Earth, like we have with the SAGE-3 investigation, which is looking at the moon and the sun through that very thin atmosphere and able to make some measurements of the constituents of the atmosphere and how they might play into climate change models. We also have an investigation known as TSIS. TSIS is the Total Solar Spectral Radiance Sensor on ISS. And this is giving us our longest record of the solar input to Earth's climate. And that is crucial. All typical climate models need to know what is the sun, what is the total energy incident on the Earth. And so that provides a very stable and well-documented resource to drive the models in that area. One of the investigations I mentioned was ecostress, which is really looking at heat sources on the surface of the Earth. Because the ISS is only 250 miles above the surface, you get great spatial resolution in the instruments on that platform. And this is showing us localized heating effects. You can see the localized heating effects in megacities and other cities where you can distinguish the cooler areas like clouds and forests from the heated areas of pavement and roads. Overall, this can help us understand the climatology of microclimates. And of course, we're proud to always have new investigations coming to the ISS through our commercial service providers and companies like SpaceX and Northrop Grumman. This is EMIT, which was just installed last July on one of our ELC platforms. EMIT is the mineral dust source investigation. And while it is there to really help us understand the climatology of dust as it picks up from deserted areas and is transported into the atmosphere and then again back into the oceans and Earth's surface, it also has a key additional benefit. The spectrometers and hyperspectral resolution of the EMIT instrument also allow it to pick up sources of methane. This is a series of methane plumes recently found over Turkmenistan, and this is allowing us to pinpoint methane emissions on the surface of the Earth. Methane, of course, is a greenhouse gas that's 25 times more potent than carbon dioxide. So understanding where these super emitters can be traced to is essential for understanding the overall concentration of greenhouse gases in our atmosphere. Again, all those instruments cooperate together. The data from OCO3, EcoStress, JEDI, and Hisui, all on that GEM platform, cover a huge range of parameters from categorizing the carbon sources and sinks in our environment to the temperature stress in our plant life and in our farming regions to the nutrients and surface minerals that we have on the Earth. They all cooperate in bringing this huge collection of resource data available so that climatologists can look at the impact over time and understand how these climate models could be integrated. Human platforms have been in space now for many, many decades. This is a compilation of photographs taken as far back as Skylab in 1973, our shuttle astronauts in 2006, and finally, Megan MacArthur in 2021 took these images of Lake Mead. Lake Mead is the largest reservoir in the US, and you can see the retreat in this time-lapse series of a number of areas of Lake Mead and it growing smaller over time. Concern certainly for the water use in the West. Lastly, our crew are an amazing resource. Through that International Disaster Charter, through their own interest, through their own outreach and speaking events after they return to Earth, we understand just what the surface of the planet means when you're off the planet. And they do an excellent job of telling us not only how that changes them, but how viewing the Earth differently can help us all understand the challenges of climate change that we're facing. Thank you.
Well, just fascinating. Thank you so much, Dr. Costello. So now we're going to launch into our conversation. I have so many questions for both of you. I wanted to begin by asking, I was very interested, Dr. Calvin, when you talked about the Earth Information Center. Is that a physical place or is it a virtual center where people can access information?
It will be both. So part of it is our vision is, the physical space is really about engaging and educating and showing what we know about Earth. But when people really need to make decisions, they're going to do it when they go home. And so we're going to have a virtual space as well that are very connected together. And we're working towards launching that later this year.
Interesting. I also wanted to ask you, It's fascinating to know there are many satellites that are collecting different kinds of data and information. How is that information integrated to give you some indication of either change and that change that could be both negative or positive, right? Are ice sheets reforming or not? How do you mesh all of that information together? Is there a computer model that this gets fed into, or how do you go about analyzing that data from these various sources?
So there's many different ways that scientists around the world take in the information that NASA collects and learns from it, and depending on the specific topic they're looking at. So there are a lot of people around the world that do what's called Earth system modeling. So they build computer programs that help us understand how the Earth system has changed, and then use that to actually project how Earth might change in the future. And those will ingest large amounts of the satellite data about the atmosphere, about the land surface, about the ocean, and use all of that together to understand those changes. There are also other people that use for specific topics can look at that information directly and infer something. And so there's people that look at how ice sheets have changed, and you can see where they've declined and what's happening with that. At NASA, we have a team that works on sea level rise, and they have taken information from several different satellites and types of measurements to help us understand how much sea level has risen all around the world in the past, and how much of that is attributed to different factors. So how much of it is ice sheet melt versus other factors, and they're doing that by combining different types of satellite information as well as information collected in other means.
Well, speaking of Earth observation, Dr. Casella, it was very interesting to see the measurement of methane emissions. We know it's very serious. What is the source of that release? Is it something that naturally happens, or is it a consequence of petroleum exploration? Is it kind of human associated? Do you have any kind of indication of why that methane release happens in different areas?
Well, large methane release can be related to a number of different factors, all the way from livestock growth on the planet's surface to certainly landfills and generation of methane gases as they decompose. It can also be related to the petroleum industry in certain circumstances. I don't recall on that one if it was traced to a specific source or not. But again, this opens up a new set of tools that we have to be able to monitor those sources and understand where the methane sources are coming from across the surface of the Earth.
That's interesting, because that reminded me, because I've heard about methane release from livestock, from cows, right? I think they're one of the biggest sources, and then also from sheep. So I guess that's true. We have large concentrations of these animals who are, as part of their digestion, right, or emitting this, or through their fecal matter. So that is a really serious issue as the population of Earth continues to grow. I'm also wondering about, as we are experiencing these extreme conditions, are there any suggestions of things that we should be looking at to help address either the warming of the planet, or I remember here in Houston, sometimes we'll get dust storms. You know, they say that I think it's from cultivation in Africa, from the Sahara, there'll be dust fields that actually move across, the Atlantic Ocean, and actually they themselves have some positive benefits, but also negative benefits. I'm wondering if you could speak to some of those kind of natural conditions, or conditions that humans are affecting, that or creating, that may in some way create some benefit for us.
Yeah, I think that's another area where EMIT is a great example of the new sources of data that we'll have to be able to provide to those models. Prior to EMIT being in place on the ISS, we only had a couple of airborne measurements of the mineral and dust transport and how that impacts climatological models. Because as that dust is picked up in the atmosphere, it also changes the albedo of the Earth and what is reflected. That impacts the overall energy going into those models. And we need to understand its role in the climate modeling chain. And that's a great reason why EMIT, its primary mission is up there to help us understand just how does that dust pick up, transport, and then redeposit itself. And even the redeposition in our oceans has significant impact on both phytoplankton growth in the oceans and overall the biosphere of Earth.
So I'm curious if we're using any of these technologies in observing other planets. I know that we are trying to better understand the climate of Mars, and I know many planets in our solar system also have climates. And I know we're talking about Earth, but I'm curious if we're beginning to do any observation of Mars and how that applies or perhaps could help inform us of the way things are trending on Earth or lessons that we can learn from the evolution of the climate and other planets.
Yeah, so we've learned a lot from other planets about Earth and about other, back and forth on that, and both in terms of science as well as technology. So some of the technologies and sensors we developed for the James Webb Space Telescope informed the sensors that are used on the OCO 2 and OCO 3 missions that Kurt mentioned. So we're learning on those sensors, but also on the science. So we've learned a lot about greenhouse gas effect and about the ozone from Venus. And with Mars, we have a lot of effort on Mars to learn more about how it's evolved in the past. And some of that can help us. Some of our climate modeling teams, the Earth climate modeling teams, are now trying to use their models to look at exoplanets. And so we can learn from that because in general, a planet is a planet. What's different is how far it is from its star, what its surface looks like, whether or not it has water, what its composition of the atmosphere is like. But the basic science behind the physics and the chemistry of how a planet works is the same regardless of the planet. It's just the conditions on that specific planet that differ.
Oh, that's absolutely fascinating. So I'm curious, where can the public go to learn more information about climate? I mean, there's so many sources out there, and unfortunately, a lot of people believe everything they read on the internet. So are there kind of go-to places that you would suggest the general public can review or explore if they'd like to learn more about climate change?
Yeah, so NASA has a great website on climate, climate.nasa.gov, and it has indicators of change. It has stories about how climate has changed, and it sort of walks through what we know about Earth and climate. If you're looking for a deeper, more technical scientific introduction to climate, the Intergovernmental Panel on Climate Change puts out reports that NASA scientists and NASA data gets fed into. And those are really good if you want a technical deep dive into it. But if you're looking for just an overview of what we know about climate, climate.nasa.gov has a lot of great information.
Well, I'm curious for both of you. I mean, you both have very distinguished careers and you have incredible mastery of lots of sources of information. Are there projects that you worked on that you found particularly like aha moments that you were really surprised by something you discovered through the data that these instruments have helped provide or provided you with a new insight or perspective?
I mean, I guess I'll go first. I mean, one of the things for me is just, recognizing how interconnected Earth is. And you mentioned it before when we were talking about dust storms from Asia affecting, conditions in Texas. Like that's something I think, until you start really focusing on Earth and Earth science, you don't necessarily recognize how what we do in one place affects somewhere else. But then for me going forward, one of my big passion areas is making sure people have access to information. And so I'm really excited about some of the efforts we've got going on now, like the Year of Open Science at NASA and the Earth Information Center, as a way of opening up NASA science and making it more accessible, both to inform decision making, but also to get more people involved in science, because we can always learn more from having more people participating.
Mm.
I think I'd say one of the big things that's impressed me over my career is just how difficult it is to keep humans alive off the planet. It makes you really appreciate the benefits that our own planet offers to us and what it protects us from, the space environment, the harsh reality of exploring space. But at the same time, I see NASA's efforts in this area to go out further beyond the surface of the Earth and to explore other planets as paying benefits back to the people of Earth. For instance, one of the major concerns we have going forward is how do we keep and take enough water with us? Water is very heavy. We don't want to travel with it. It would be great if we can process it remotely in areas like the moon or Mars. But we are also doing our best efforts, and we've done so on the ISS, to close the overall water loop. In other terms, we want to make sure that we can recycle the maximum amount of water possible so that we have to bring less with us. Well, those same advancements in water recycling technology, water purification technologies are even implementable on Earth in areas where we don't have necessarily remote access to pure water and other things. We've taken technologies and lessons learned from that into those areas. We've also done steps forward in how to produce food. Of course, food is an area where some nations face huge food insecurity. And so being able to produce that food with a minimum number of resources and really preserve our Earth's capability to support the overall food production is a great area of research that coincides with space research. Our ISS National Lab has sponsored a target sustainability challenge where we were looking at more efficient manners to grow cotton. Specifically because cotton is one of the plants that requires a significant amount of water investment in those crops. And to see excitement from the commercial elements being interested in promoting sustainability challenges and also to help NASA with its mission to take precious resources with us as we travel throughout the solar system has been an exciting development.
Just fascinating. Well, I wanted to ask you each, how did you end up in the roles that you're in? Kind of, what are your paths to becoming climate specialists? And we've heard a little bit about your career trajectory and the things that you've done, but really kind of taking you back to your early years of life, were there particular influences or experiences that got you interested in these topics?
So when I was in high school, I didn't really know what I wanted to be when I grew up. I just knew I liked math. So when I went to college, I was a math major initially, and I added computer science, but I've always liked being outside. And so when I got to grad school, I started doing research on climate change because it was this opportunity to bring together my math and computer science skills with something that I cared about, being outside and seeing Earth. And that's where I got started in climate with NASA. And my first couple of memories of NASA, one, I did a family vacation to the Kennedy Space Center Visitor Center when I was maybe 10. And I have a memory of taking the bus tour. I also remember seeing an alligator. I also learned a lot about NASA through movies. So I really liked Apollo 13 and sort of seeing, a team work together to solve a problem. And so I've kind of followed NASA all along. And so then when I got this opportunity to do climate and science at NASA, it just seemed perfect. And so I've had, a really great time over the last year and a half. I have the coolest job ever.
Great. Now, how about for you, Dr. Costello?
Yeah, I think Kate's really enthusiastic answer goes along a lot with mine. I had a dad who was very inspired by the Apollo missions and Apollo engineering. He got me excited about space when I was just a kid. And I followed that into a career path in STEM, in math and physics. And when the opportunity came to come down to Rice, I got to interact with the people at Johnson Space Center and understand more of the mission, more of the human spaceflight mission. And by then I was pretty much hooked anyway. I was doing research into some of our upstream solar wind satellites that we had and trying to determine how the solar wind interacts with Earth's own magnetosphere and atmosphere. And I wanted to continue that science career with NASA. So I took a job at NASA early on. It wasn't particularly in the science field, but it was training crew members and flight controllers how to operate the space station. We weren't quite at the point where we were fully sustaining a lot of science on space station, but I knew eventually I'd get back to that. So when the opportunity opened up in 2011 to move into the science program here, I was all over getting back to science and being able to take all those lessons learned that we had during the buildup and development of the space station and now put them to use to bring about the most efficient and most beneficial uses of science on the space station.
That's fascinating. And I'm also very happy to hear that going to science centers were formative for you and for both of you and helped you pursue your passions in life. I'm curious if you're willing to share with us or able to share with us what you're working on next. What's kind of on the horizon for kind of new projects or new research that you're hoping to advance?
I think
guess
I already highlighted the big thing I'm working on. So I'm working on Earth Information Center, and it's a part of a broader open science push at NASA, where all of our data is publicly available, but we're really focused on making it easier to use and engaging more people in NASA science and in NASA climate and NASA Earth. And so that's the big effort that I've been putting on right now.
Thanks for the question, William. I think the most exciting thing about the International Space Station is that we do all types of science. And so when we talk about the next thing, it's really usually about the next 250 things because we're flying about 250 payloads at any given time. So as we plan for the future, some of our big areas of focus are again, Earth sciences, rounding out the capabilities we have on the outside of the space station, but also some of our life sciences and physical sciences inside the space station. We're looking at upgrading a few of our facilities to last now that we've been extended through 2030. We're very excited about that extension plan and the ability to do more science in the facilities, but a few of them will probably need upgrades. And we're also extremely excited about how to transition from ISS to a commercial LEO destination where we can continue doing Earth science and other science in the low Earth orbit environment. So as we work towards that transition, sometime after 2030, we'll be working with the commercial LEO development program to figure out how to move the science from ISS to those other platforms.
Well, something that is very well documented among astronauts is the overview effect. And of course, that often happens when astronauts go to station and they're looking back at Earth and they develop this phenomena that they care deeply about Earth. They don't see nationalities or national boundaries and really care very deeply about it. And I'm curious if either of you have kind of understanding or insights around the overview effect, and how is it that humans have this this kind of a response and kind of change perspective. And it's very well researched, but there are a lot of differing views and opinions about overview effect and what's really the cause of it.
Let me go ahead and try that one. Of course, I would love to experience it the same way our astronauts do, but they do an amazing job of being able to translate that experience for us. You said part of it is that you don't see the borders. You don't see a lot of man-made infrastructure on the ground, but you do see it at night, especially as the cities light up. You get different perspectives from being above the atmosphere than you do being below it. You don't have the light scattering effects. You see all types of new phenomena that are hidden, upward moving lightning, like in sprites, red sprites and blue elves. The phenomena of the aurora. It is just amazing to capture. And when you consider, not only are they capturing this, but they're seeing the cycle of our planet. So sunlight and eclipse, 16 times a day. You get all of this in a fast forward sense. So it's not only the sense that our environment is very fragile and that it's unique and that has all these amazing features, but you're seeing the extent of those 16 times a day while you're on orbit. The crew comes back, I would say, changed if it's their first time flying. That experience is amazing for them, and they're able to translate it to us in unique ways. One of the best examples I can give you of that is Don Pettit, when he was on orbit, tweaked some of our cameras to be able to take time-lapse, very low light movie sequences of the Earth's surface. And in doing so, captured the magnificence of thunderstorms as they roll across the surface of the Earth and the aurora as they interact with those. Our astronauts not only participate in a lot of the earth science that we do, they come up with methods on their own to capture some of this beauty and bring it back to everyone here on the planet.
Well, I know that many people experienced elements of that when that beautiful image was taken by Bill Anders. And I love the fact that, Dr. Calvin, you have that image on your wall because it is so important and it has resonated with people for decades. And I think it's one of the most duplicated images ever from space. So it really is a way, I think, that some of us who've not had the opportunity to go to space have a little bit of that overview effect. And I also loved in your presentation the image from Orion, looking back at both the moon and Earth. I mean, I think it's one of the most spectacular images of the year. So I'm so happy that you included that in your presentation. We're getting close to the end of the time of our conversation. I've been having a great time speaking with both of you and wondered if you had any final thoughts that you'd like to share with our viewers about the work that you're doing or about the climate of Earth.
Yeah, I thank you so much for having us. It's a fantastic discussion, getting to hear a little bit about our satellites and about the International Space Station. And I guess just for some final thoughts, we're continuing to study Earth and learn about it and try to get that information out so we can help people understand what's happening in their communities. And we also try to include ways of people to engage. And so we have a lot of citizen science projects that you can look into if you want to get involved in NASA science, if you want to learn more, climate.nasa.gov or any of the nasa.gov websites have lots of information about what we're doing.
Yeah, Kate, I think you hit it on the head there. Not only are we doing research, but we want the communities to be able to participate in that research. There's some great resources out there for the investigations. We fly on the ISS, everything that's going on a daily basis. One of the best ones is the Space Station Research Explorer. You can simply Google SSRE and you'll find that one on the web. And that details all of the investigations, and you can search it by investigation type, whatever interests you about space investigations that may be going on. Technology demonstrations, earth science, physics, life science, it's all out there. And the ISS is always excited about not only that aspect, but STEM education as well, how we get the information, why we're flying, and why we're doing research in space out to those students and inspire that next generation of researchers for the future.
Fantastic. Well, that's the perfect close. I want to thank you both so much for joining us on our Thought Leader series and thank all of our viewers as well. I want to remind everyone that you can see this episode and others at Space Center Houston's website, spacecenterhouston.org. And we look forward to having you join us on another episode. Again, Dr. Calvin, Dr. Costello, thank you so much for sharing so much fascinating information with us about the research that you're doing and the work of NASA and understanding Earth's global climate.
Thank you.
Thank you.